So we do not want any imaginary values. We don't want complex numbers in the denominator. So what do we need to do? We must multiply both top and bottom by the denominator's conjugate. We need to multiply both top and bottom by the denominator's conjugate to get rid of the complex number on the bottom. So on number 1, let's all take a look at this binomial, this complex number, and let's actually multiply it by the conjugate. What is the conjugate?
1 minus.
Yes, 1 minus 2i. And I am going to do it to the top and the bottom. So I'm going to put times 1 minus 2i. Now, why am I multiplying by the conjugate? Because the imaginary values will disappear. When you multiply a binomial or a complex number by its conjugate, the imaginaries disappear. Watch the magic happen. You have 1 times 1, that's 1. 1 times negative 2i, that is negative 2i. And then you go 2i times 1, that's positive 2i. And then you have positive 2i times negative 2i. That's going to be a negative 4, and then I squared. Now, the middle values, like I said, when you multiply the binomial with its conjugate, they cancel out. And what about the I squared right here? You know you're going to replace it with the negative 1. So what do you have left? You have 1 minus 4, but we're going to put times negative 1 instead of the I squared. So that's really going to be 1 plus 4, right? The 1, and that's really going to be a positive 4 because a negative 4 times a negative 1 is a positive 4. Final answer is 5. Now, what did I just find? I didn't find the answer yet. The only thing I found was the new denominator. See how all this is on the bottom? This is the new denominator. Now, what about the numerator? Well, the numerator, I need to distribute 3 times 1 and get 3, and then 3 times negative 2i and get negative 6i. So on top, let me write it. 3 times 1 is 3. 3 times negative 2i is negative 6i. And we said that it's going to be over the new denominator 5. So again, the key to this type of question is you do not want an imaginary number in the denominator. So we're going to get rid of imaginary numbers by multiplying both top and bottom by the conjugate. And notice that when you multiply by the conjugate, there is no more imaginary on the bottom. Now remember, a complex number is 2 pieces. You have the real part and the imaginary part. So I need to get this 5 and put it underneath the 3 and put it underneath the 6 and write them separately. So I'm going to go 3/5 minus 6/5 with an I. This is your final complex number answer. I hope we understand that. Let's try one more. Let's take a look at number 2 here. Of course, you could go back and watch this on Edmodo and pause it. I am going to multiply by the conjugate. What's the conjugate? 2 plus 4i. Now, why am I doing that? Because I know it's going to cancel out all imaginary values. What I do to the bottom, I have to do to the top. The same exact thing, 2 plus 4i. Let's work on the bottom. What's 2 times 2? Oh, that's 4. What's 2 times 4i? Oh, that's 8i. Positive 8i. And then what's negative 4 times 2? Oh, that's negative 8i. And then what's positive, or negative 4i times positive 4i? That's going to be negative 16i squared. And like we said, when you multiply by the conjugate, those i's in the middle, they end up disappearing. And this I squared is always going to be a negative 1. So you really have 4 minus 16 times negative 1. That's really going to be 4 plus 16, which equals 20. Right? Now that 20 is just the denominator. Look, all this work was from the bottom. So the 20 is just on the denominator of your answer. What about the numerator? What are you going to do for the numerator? You have to distribute for the numerator. So take that 5 and go 5 times 2. Oh, you're going to get 10. 5 times 4i, you're going to get plus 20i. Now that's on the top. So you have this on top and you have the 20 on the bottom. Let's write that as the next part of our answer. So 10 plus 20i over 20. You guys with me? And of course, you want to write it as two separate pieces. You want your real part first and your imaginary part second. So I'm going to take that denominator of 20 and split them 1 to the 10 and 1 to the 20. Now when I do that, it actually works out pretty nice. You have 10 over 20 plus 20 over 20 with an I. So could he do anything else? Yeah, you could reduce the first fraction. That becomes 1/2. And 20 over 20 cancels. So your final answer for number 2 would be 1/2 plus I. 1/2 plus I. There will be one of these on the test Friday. Now that doesn't mean you should say, I'm going to skip it, because about 20 questions, each question's about half a letter grade. So please make sure you understand this, right? Would you guys like to try another? Yes. Okay, number 3, might as well. I'm zooming in a lot because there's not much space. I am going to multiply this denominator by the conjugate. What's the conjugate? Minus 2i. The only thing that changes is the middle sign. You change it. So I need to also multiply the top by negative 3 minus 2i. Okay, so let me start with the work on the bottom. What is negative 3 times negative 3? Positive 9. What's negative 3 times negative 2i? Positive 6i. What about positive 2i times negative 3? Negative 6i. And what about positive 2i times negative 2i? Positive 2 times negative 2 is negative 4, and I times I is I squared. Are you with me? Now, the middle values are going to cancel out. We already knew that. When you multiply a complex number by its conjugate, the middle numbers cancel out. And what do I have left? I have a 9. I have a minus 4. Now, don't forget about this I squared is really a negative 1 times negative 1. So you really have 9 plus 4, because the negative 4 times the negative 1 ends up being a positive 4. So that's really a 9 plus 4, which final answer is 13. 9 plus 4, final answer is 13. But this 13 is only the denominator. So all this work was on the bottom. This 13 is only the denominator of my answer. Now what's my numerator going to be? This one's going to be kind of challenging, because on the numerator, this is also a binomial over here. So I need to distribute both terms also. So I want to go 1 times negative 3, that's going to be a negative 3. 1 times negative 2i, that's negative 2i. And then I go 2i times negative 3, that's going to be a negative 6i. And then 2i times negative 2i, that's going to be a negative 4i squared. Now, the middle terms do not cancel out right here. The negative 2i and the negative 6i, that ends up giving us a negative 8i. So let me rewrite this. I want to take this, all of this, and simplify it, and this is going to be the answer on my numerator. So this guy and this guy is going to give me a negative 8i, correct? So I really have negative 3 minus 8i, and then minus, what do I have over here? A 4i squared. But that I squared is going to be times negative 1. So minus 4 times negative 1. Okay? So what do I really have up on top? I have this negative 3 that I could combine with this positive 4. Negative 4 times negative. So if I combine this negative 3 with this positive 4, I'm going to get a positive 1. Okay? So I really have positive 1. Whoa, sorry about that. I really have a positive 1 minus 8i, and that's my numerator. That is my numerator. Now on the denominator, I have what? 13. So I need to put 13 down here in the denominator. The only other thing I could do is split it, the 13 into each one. So my answer is going to be 1 over 13 minus 8 over 13 with an I over here. That's my complex number answer.